my name is Aanchal, and I'm like co-head of the ML Tech team. I mean, Tech Club's ML team, and Benjamin is my co-head. So we'll be talking about we'll be giving a quick introduction to AI, ML, NLP, and an overview of a planned project that we have. So let's start off. With Benjamin.
Yep, sorry. Aklan, can you add people to the group because they can't see the chat in the Teams? Some of them don't have access to this chat. Okay, so artificial intelligence. So when we talk about artificial intelligence, what do you guys usually think? Is it something human-like, or is it something that's something just computerized, or those kind of things? Do we actually relate them to human intelligence? Because by textbook definition, it's just the ability to make a decision like a human would. And it's like someone, you're doing a certain task, someone tells you, oh, you do it this way, and you go like, okay, the person's given me some sort of advice. Now how do I apply it, what he's told me over here? Now that's how a human cognition would work. So for an artificial intelligence, it's basically somewhat similar. It's like taking information from the environment or any sort of information it gets and putting it into context and using it in your this thing, in the whatever problem it's solving. So let's see, but there's a problem. Right now AI, or the development of AI, is very distant from what we actually think an AI can do, because of movies and stuff. We think the AI is like, they're completely autonomous, they can speak to us and stuff, but it's very different. Why? Because right now, even though the process of getting information is autonomous, like you have from cameras, you have sensors, it's all autonomous. You get it without humans having to physically manually feeding in data. AI is still just a simulation. It's not really sentient, or it doesn't have self-awareness. And I would say we're far off from it, like maybe a decade away, a couple of decades away from it, from ever reaching that point, because we still haven't cracked how human learning works. I mean, we say that, we understand how a human learns, so we, go to schools. Like, see, schools teach children. But truth is, the way children learn is still somewhat unanswered. It's kind of still unknown. So AI is a much more smaller version of what a human learning is. We're just like looking at how a human learns, keeping that as a gold standard, and we're trying to build a system. So it's like we've not fully understood what the gold standard is. So we're still making a system that's still incomplete, I would say. So people have concerns, is AI going to take over? I'd say no. We're far off from it, but maybe, we never know what the future holds. But hey, and there's a problem when we say AI, because now that we've come to we're coming and we're going to be talking about ML, NLP and stuff, but people go like, oh, isn't that AI? Yes, it's AI, but you need to understand it's not the same thing, because AI is an umbrella term, and that's an issue. Not an issue per se, because it's still correct, it's technically correct. But the problem comes is people start to generalize things a lot, and they don't really understand how deep this goes, and that that takes it to a point where people either over glorify AI or they under glorify AI. Like, they don't take it seriously, or they take it way too seriously. So let's see what AI really is. Like, let's look into that. So what AI is, like, do you guys at the chat have any idea what AI is? I'm not sure if most of you have access to the chat. If you don't, you can switch on your and speak. That's fine.
Benjamin, if they can't access the chat, they can even use the Tech Club WhatsApp group.
Actually, yeah, you can. Yes, you can use the Tech Club WhatsApp group. I will keep that open here. So if you guys have questions, or you can speak up. There's no harm in speaking up. Like, I'm more than welcome. Okay. Okay, so they'll use WhatsApp. Okay. So if you guys have any questions, let me know. I'll keep the WhatsApp open over here. Okay, so AI is just, I would say it's, funnily enough, it's glorified automation at this point in stage. Like, I mean, not fully though, but a few years ago, yes, this is just a glorified automation. Like, you would say, oh, you know what, they do this task. Like, move this particular vehicle from point A to point B. Now that's automated. You can automate it to be like, set the motor speed and set for how long it has to run, or like based on a GPS coordinate. If it's at this position, stop the motors, or run it. But then as we progress, we found out ways to make that automation much more better. And that is where why I said it's glorified automation. So here's the thing. AI is far from human intelligence standards. Like I said, we keep human intelligence as the gold standard, or glorified AI is real steel and nothing else. Kind of, yes, at this point, but hey, you never know. Probably in the future it might change. So, I mean, research is moving to the point where we are talking about long-term memory models, where rather than just killing them at the end of their learning process, they actually learn to use it in another context. So yeah, it's a bunch of if else's right now. That's true.
Or Benjamin, you can even call it like a dot product.
Yeah, yeah, yeah. You could call it that. Yeah. Like I said, so coming back to the slides, it's far from human intelligence. That is because the way a human learns is still, I would say, untapped. I mean, we do have a certain understanding that if you look into the field of psychology, you have a fair understanding of how a human learns, how a human uses information, but that's far off from what we really require to model, because humans have always copied nature as a form of getting uh, their inventions. Like, you look at an invention of aerodynamic cars, it comes from the whale or the some of the fishes, because how they reduce drag when moving through a fluid medium. Aircraft, they follow the idea of birds, the wings. That's what the wings of birds are what inspired the wings of planes. The same way we in artificial intelligence or in machine learning, we look into humans because that's what we consider to be the gold standard. We're like, how do they learn? So that's why I said AI is an umbrella term, because we have not really cracked it. At the same time, any small advancement we make, we say it's AI. That's why we've not achieved strong AI or true AI. What we have is weak AI, I would say. So now AI today, if you look into it, is, as Guava mentioned earlier, there's a bunch of if else statements. That's actually the rule-based system. It's it's everyday if else statements most of you might use if you program. If you don't in programming, if else or conditional statements, like if this is the condition is true, then do this action, otherwise do something else. That's actually the AI that you would see is most applied, or when people say that, oh, my company they implement AI, it's nothing but a glorified if else program. It's surprising that it passes as an AI. And then we have machine learning. Now, this is actually the hot topic of I don't know, like in the past year, in 2020, especially with the situation around the world, with people working from homes, people have been diverging into learning new things, and all of a sudden, machine learning has become a really interesting field. Uh, okay, so what machine learning is basically, we'll look into detail what it really is in the next few slides. But in short, it's basically telling the program, this is telling the computer that this is the inputs I have, and this is the outputs I want. Now you figure out what the pattern is or how you're going to get there. So that's basically, it's a bunch of algorithms that's capable of doing. Is an attempt to mimic the human brain. Basically, we try to copy how the neurons in our brain work, like how they fire information with each other and they work. It's a type of mimicry we try to do. There's actually a very interesting paper for that. I will try referencing that in the group later on. But that paper was really interesting, where they say it's basically they're trying to mimic the human brain, because that's the best thing we know, and we're like, what, let's try copying it. But it's so complex that the nodes or the neurons we use in machine learning or in neural networks is actually a simple mathematical model. It's not as complex what our brain is, like what our brain has, but it's actually a simplified mathematical model. And the interesting part is putting a bunch of those models together, you can actually convince it to, you can do parts of what human cognition can do. You can achieve certain parts of it. It's really interesting. Now, the fourth thing, deep learning. Now, while making this, we actually had a discussion with Aanchal and I were having a discussion, because we were like, what's the difference between machine learning and deep learning? Isn't it the same thing? And during our research, we actually found out deep learning is actually an application or a subset of machine learning, because end of the day, both of them are teaching a computer or a system to learn. But deep learning involves stacking neural networks. Like deep learning is an attempt or an application of like neural networks in an attempt to mimic the brain. So what happens in deep learning is you've like maybe thousands or hundreds to thousands of neurons that are interconnected, and they actually fire between them, or they pass data between them to find patterns. And it's basically an interesting model with they imply weights to give certain because they might be like, oh, this neuron detects these patterns, so they need a higher weight, and it's an interesting application. Then we have predictive analysis. This is where statistics kind of, because people have confusion between data science, statistics, and machine learning or AI. Which one do I take? Predictive analysis, while not exactly true, but I would say it's kind of like the bridge, because statistics is basically finding patterns in data. That's basically it. AI again is at the same point. It's like, oh, you're finding patterns from data, or how to use the patterns that you find in the real life world and like applying it in context. So it's kind of like a correlated, not fully correlated, but kind of correlated. And predictive analysis is where you have, based on a model, you're able to predict what an unseen data is, or it kind of shares roots with pattern recognition. Like in pattern recognition, for example, you give it an image, and then it's able to identify what it's there in that image. In predictive analysis, you're basically like in NLP, we will be using it. Given a sequence of words, what is the most likely word that will come next? Those are a few examples, and there's a lot more, but we'll just keep it here for today. You guys can reach out and you guys can research, look up. There's a lot more applications for AI today. It's really booming. So, and then we have, this is actually another question that people ask most commonly. What is the difference between ML and AI? And like I said, I would cover this. So AI is an umbrella term. It's the broader concept, or the entire field is called artificial intelligence. Yeah, because it's trying to make intelligence or mimic intelligence that humans possess, or that's seen in the organic world or in nature. Machine learning is just the current application of AI, or what that means is what little we've actually unearthed from this particular field, we're like trying to put it into use in everyday life. That's machine learning at this point. And it's based on the idea, like I said, you give it a bunch of input and you show it what an output's supposed to be like, or in when you actually program, you would call it labeling and expecting a label to get back, or like predicting what's the likelihood of it being a certain pattern or it matching a certain pattern. And the machine is required to figure out on its own, like what are the parameters I have to set, or what are the what are the values I need to set within myself to figure out that given a certain input, I'm able to give a certain output. And that's what machine learning is. And actually, as Aanchal will speak in NLP, you will see how NLP is structured and how it's used. Now we have NLP, and I will pass it over to Aanchal.
All right, so just a quick introduction to NLP. NLP is natural language processing, and it's a branch of AI and a subset of ML, or actually an application of ML, as you will see in the next slide. It's a field of study attempting to bridge the gap between human communication and computer understanding. So basically, NLP, the field of NLP has the goal of making it easier for humans and computers to understand each other. And you've been interacting with technologies that use NLP for a very long time and probably might not have realized it, or maybe you have since you all are interested in this stuff, right? So, for example, actually, before we get to that, I just want to mention, don't confuse the computer science NLP, which is natural language processing, with the other NLP, which is neuro-linguistic programming. That is a part of psychology, and usually when you search on Google stuff like what is NLP or how does NLP work, this is what comes up. The psychology is what comes up. So if you want to look for natural language processing, type the whole thing out. Right, back to the topic. So if you call for Alexa and you ask her, Alexa, can you set a reminder for me to go to the gym at 5 p.m.? She'll respond with your reminder has been set. This is the evolution of NLP over the past few years. It's moved on quite a lot, and like you see it all around you, Alexa, Siri, and so on. It's an application of machine learning with the goal of improving communication between humans and computers, obviously for various reasons. Now, why exactly is it important? Other than being used for improving the communication between humans and computers, it's also important for the management of data. Now, as everything related to the field of AI tends to boil down to, NLP is no different. Data provides importance to NLP. More specifically, NLP has its purpose in handling large amounts of data and structuring highly unstructured data. The amount of data that's generated every day by every person is 2.5 quintillion bytes, or around that. Even if that's not an exact number, even as an average, that's a lot of data per day per person. Managing all that data is what the whole field of AI is dedicated to, and NLP is dedicated to making it easy to understand and convey to humans. Right. Now, structuring highly unstructured data is the other reason for NLP. For example, tweets on Twitter, so and so, you can understand them. You and me can understand them because we're humans. However, if a computer was to read this, it would get confused with the slang and the emojis and the incorrect grammar and so on. So, there have been cases where people try to, there have been cases where
Hello? You can't hear anything?
I think she went on mute.
Hello? Oh, I think maybe she might be having some.
Sorry. No, sorry. It got muted by mistake. Right. Okay. So there have been cases where NLP is used to create systems that look through tweets and so on. For example, if anyone's heard of Tay tweets, we'll see that coming on. So as you can see, the importance of NLP is in dealing with data and communication between humans and computers. Areas of NLP include an area called machine translation, which, fun fact, was actually what NLP started out as in the 1950s. So the first ever application or study of NLP was under the name of machine translation. Now, however, it is only one of the many areas that NLP is known for. I won't go too much into depth in these since they're very broad and require decent research and a lot of time to explain properly. I'll be covering a simple summary of what each of them means. Content categorization is used for linguistic-based document summaries and including search and indexing, content alerts, and duplication detection. So it's used to categorize pieces of text and bodies of text into custom categories or set categories as provided before. Topic discovery and modeling. This is supposed to accurately capture the meaning and themes in text collections and apply advanced analytics to text like optimization and forecasting. This is similar to a process in text analysis known as qualitative content analysis. It's used in the fields of psychology, linguistics, and now computer science to take pieces of text that have a lot of information and find themes in them and use those themes to get values or something that can be used as to predict or used for analytics in a numerical fashion. Contextual extraction is fairly straightforward and simple as it says. It's to pull structured information from a text-based source. And sentiment analysis is for identifying the mood or subjective opinions within large amounts of text. For example, if you wanted to see how your product is doing, you use sentiment analysis to go through the reviews and see if the reviews are good, bad, angry, what's going on there. Speech-to-text and text-to-speech conversion. This is, again, fairly straightforward, and it's about transforming voice commands into written text and vice versa. Document summarization is about summarizing a large body of text, generating synopses of large bodies automatically. As Ben mentioned before, this is all glorified automation. Machine translation is the specific job of translating a text or speech from one language to another. And text generation is automatically generating new bodies of text following a given theme or input. So there's many uses of NLP, and there's many areas where it can be used. However, we will be talking about how it can go wrong as well without the right data sets. Now, coming to talk about the importance of data sets, back to Benjamin.
Okay, so data set. Now, Aanchal introduced data set, but what is a data set? I mean, pretty much more, I'm sure in this right now over here, most of you know what a data set is. It's a bunch of data basically that you would use to train a model. But what makes a good data set? You know, what is a good data set? Do you guys have anything like, what do you guys think is a good data set? Would you guys can put in the chat.
Is it structured data?
Yeah, structured data. A structured data would be good. Would be part of a good data set. Yes. Anything else? You can unmute if you guys want to.
Can I answer?
Yeah. Okay.
No. Okay. Fine. Continue.
Okay. So let's take a look at what really defines a good data set. Okay. First thing is it shouldn't have missing values, or by missing values, what I mean is missing data. Basically, if you have a data set and you're giving the computer this data set, and you're like, okay, in this data set, these patterns or whatever how you train yourself on this should yield this particular output. Now, if your particular data set had missing values, that's incomplete data, and now your model is undertrained, or it doesn't know how to fill those voids of missing data. That is why we say a good data set shouldn't contain missing values. Now, the next thing it shouldn't be it shouldn't have aberrant data, or basically data that's not standard. And what is standard, you would ask, for a data set? Well, it depends. I would say for each and every application, or like whatever your current application is, it depends for that. Suppose, for example, if you want to differentiate between a pen and a pencil, if you are like, yeah, something similar, it's really similar. Now you keep pen and pencil, and you start taking it from far away. Now that data, both of them are going to look like like a stick. So it's equivalent of telling both of them have a cylindrical shape, but you're not really defining the features. Usually a pen or a pencil is differentiated by its features, like the lead tip is part of the pencil's features, while a cap is part of a pen's feature, generally speaking. So kind of having non-standard data, or having duplicates of each other. Like if you have pictures of the pencil inside the pen, say the algorithm is like, oh, this is a pencil, you know what, let's add it. So when you show it, when you're asking it to define what it is, the algorithm will wait, is it a pencil or it's a pen? So it starts getting confused. That's one of the reasons why we say it shouldn't contain aberrant data. That's why we do filtering. Then it should be easy to manipulate. Now this comes because when we give large amount of data sets, if we give a mixed data set, like pens and pencils, the images are together and you give it to it, how will it separate? How will it differentiate it? We have to probably when we give it data, it has to be differentiated. Like when we open the folder, we'll be like, okay, this folder contains pencils, this folder contains pens. It makes it easy for the system to be like, okay, whatever data I get from this folder would be pencils. Whatever data I get from this would be pens. That makes that learning process easier for it, or it doesn't confuse the model while it's learning. Because even with the human child, you tell the child and you teach it the letter A. What we learn as letter A. Suppose you tell the child this is letter A, and someone else tells them the letter is B, like the teacher at school. Now the child is confused, like who's right, and he would always have that sort of confusion within him. So that's why we say it should be easy. It should be logically divided or easy to manipulate. So for a child, when you say this is A and the letter B is something else, he's able to differentiate between both of them. So that's kind of that learning we are trying to achieve even in systems, AI systems. Next thing is it should be easy to read or understand. Now this comes specifically because NLP is involved. If you give it a bunch of gibberish to the NLP system, the NLP will be like, okay, then that's the standard it knows, that's what it's learned. It would output gibberish, and now we don't want gibberish as output. I mean, unless you're training a model for that particular purpose, then by all means, that would become the standard then. Otherwise, you would want to make sure the grammar is correct, or you would want to make sure it's part of a string, because giving it a bunch of characters on its own, it wouldn't know how to concatenate it and make meaningful sentences out of it. You give it meaningful sentences, and you'd be like, okay, you know what? If you have this sentence, then this is a sentence. This is actually a sentence we use in real life. So the system goes like, okay, you know what? That makes sense. So after this particular word, the probability of something the next word is going to be this. So that's how it's designed. So now, actually, for images, I will actually show you right now that I'll do a small demo. I'll switch to the demo. We're going to do a demo on Teachable Machine from Google. It's basically, you guys can go mess around there. I would encourage you guys to mess around there. It's interesting. Someone has a question? Yes, Pranav.
Benjamin, so I've noticed in your importance for a good data set, you didn't mention data bias.
Data bias doesn't?
Like bias human side. So
Can I?
Yeah. Yep.
Yes. Okay. Okay. You didn't. Yours isn't exactly a question, but I'm going to talk about it as well. It's in one of the coming slides, but maybe it should be mentioned here as well. So data bias is actually one of the most risky parts of creating a data set. It's something that's very hard to avoid because the source of it is humans. I'll be giving you an example further on, but for now, let's say you're creating a bot for hiring purposes and to go through CVs for you. If you give it previous data on how you hired or what candidates you chose, which candidates, it's going to learn from the habits that you showed it, and it's going to hire. One such example did actually happen. Someone did create a bot based on this. And what ended up happening was the bot turned out to be racist because the previous hiring, the data set that was provided, which was the previous hires, was skewed towards white males. So the bot also prioritized white males as it learned from the previous data set. This is called data bias, and this is something that's hard to avoid because it's hard to spot. We'll be talking about it a little bit more as a little later in the presentation. So for now, back to Benjamin and his little demo.
Yep. Okay, so yeah, so I'll switch to Teachable, and let me know if you guys can see. Yes, I believe you guys can see the demo.
Benjamin, can you increase the screen size a bit more?
The screen size.
Sorry, just 1 second. Pranav, was that enough, or do you still have some anything else about that?
Benjamin,
sorry?
Okay, now it's much better, I said.
Okay. So this is basically the Teachable Machine from Google, and what I've done is I'm going to actually demo what I would categorize as a good data set, or it isn't the perfect data set because data is always dirty. That's kind of the general thing. But what I've done is this is just to show a simple demo of why a good data set. So these are a bunch of images of drones that I've taken earlier, and that's denoting it as the green drone. And I'm calling the next one the ESP copter drone, basically the two types of drones. Now, the reason this being a good data set is because you can see that most of images in this data set is just the drone in focus with different angles at it. Yeah, so it's easy to spot the drone from any direction. Even for the other one, literally the same. I've taken images in various angles, lighting, so it's easier to identify. So once we give it to train, what happens is the image is actually if you upload images, one second, once it starts training, it'll actually do a filtering process. If you give it an irregular shaped image, it will basically make it into a square, and it will start applying, see, as you can see over here, they will crop it so that only the center is taken. So that's one way of standardizing the images that come in. It's part of filtering. So it's trying to make use of whatever imperfect data you get it, try to get it close to at least the accepted model, you know. So what happens is here, I'm just leaving it all in the default settings. Basically, epochs in machine learning is the number of times the iteration takes place. Path size is how many images you give into it, and how many it's divided. So the entire data set cannot be run at once. So in this example, it takes 16 images, runs it through the this thing goes to the next 16 images, runs it through it until the entire data set is converged. And once that is done, it basically calls it one epoch, and then it goes to the next one. And then the learning rate is how quickly it changes. So most of you are from year 3. I'm pretty sure you guys know what learning rate is, like how often the data is the model in memory is actually it is changed based on the information given from the system. So now let's take a simple demo. So okay, there's actually an interesting thing. Imperfect data yields this. At this point, there's no drone in the particular image it sees, and it still shows me that there's a probability of the green drone being there. If I look like a green drone, well, good. Otherwise, no. Here's an example. Suppose I bring in the ESP copter into the frame. You see, despite it not being anything similar to where the ESP copter was actually kept on the table earlier and taken pictures of. Here it's held in the air. It's shown in different angles. And you can see that the likelihood of what it is or what the model predicts it to be is of the correct type, is of class ESP copter, because it's been specified earlier. Now this is a green drone. You see it has green colors while the ESP copter doesn't have a green. So you see it's able to find out what each one is as it. This is what a good data set allows it to do. Even if there are two things, you see it is able to focus on what's ahead of it and what's behind it. Yeah. So that's actually one of the advantages of having a good data set for learning. Now we'll actually switch to another demo. So here let's take a dirty data set basically. Let's try to figure out what a dirty data set would be. So let's go to the webcam and let's be like pen versus pencil. Easy thing to demonstrate dirty data set with. So I'm going to record this particular pen in different this thing. And now what I'm going to do is I'm going to put it behind, so it's like small. So you see the data it's not standard, it's all over the place. And we can add a few of the pencils in there. So it's like, oh, confused. So let's call this the pen. And then we have the pencil out here. So what you can do is you can use the webcam again, and this time let's add the pencil. Yeah. So let's bring it closer and we'll be like, this is a pencil. So you see, in different angles and stuff, it's the pencil. I'm gonna add a few of the pencil to show the dirty data set. Okay. So right now we've collected 198 and 169 image samples. So we'll leave it on default and we'll be like train the model. What happens now is, because this has a very bad, this is going to be very inconsistent also, because I am a primary subject in there. So that's not good, because it's deviating away from that pencil as the primary object, or in this case, the pen as a primary object. That's an example of bad data, having unwanted data in your particular model set. Look at this. It's telling I'm the pen. I mean, because when I train the images, I'm in focus. So it would say I'm the pen. I bring the pen, no change. I bring the pencil, it detects it. I mean, your model would work. So it's going to be very difficult to find. But do you see what's happening on screen? How the prediction is confused? Like, it's like, is it a pencil? Is it a pen? What is it? It's kind of like, see, even with a pen, I'm just holding a pen up on screen, but it's so confused based on what it is. This is what a bad data set does. And the problem with a bad data set is and like how Pranav brought out data bias, you wouldn't notice it or you wouldn't spot it until the very last. I mean, when it's executing, you're like, wait, why is this not working properly? It could be to do with your data set sometimes, So that is actually one of the few things that you should take care of. That's why a good data set is important when it comes to machine learning. So now I'm going to send it back to Aanchal. Aanchal, yeah.
Okay, so now that we know how important the data set is, we have a little task for you. I hope you guys interact. So can you find the appropriate data set for any one of these 4 scenarios? Okay, wait. First of all, is anyone interested in performing this task? Otherwise, we'll skip it and move on. If you're interested, just raise your hand.
Yeah, actually, raise your hands. It'll be. We have Vibe.
Right.
Okay, we have Aklan. Oh, nice. We have Harshal too.
Great. Okay. So pick any one of these, and you have about 7 minutes to go find a decent data set. But here's the thing. Usually data sets take a lot more time to meaningfully decide. So for now, you're going to have to use the summaries that you find online instead of actually looking properly into the data set.
Yeah,
Also,
just suggest data sets.
yeah, I'll suggest some places to find them. But first, you have a question?
Vaibhav,
yeah. Okay, did you not
Yeah,
have a
I think-
question?
No, I
no, I
think
think
they
you
just
wanted
wanted to
to,
say
yeah.
they're interested in it.
Oh, okay.
Alright.
Okay, cool.
So one place to find data sets is obviously Google, but you got to know how to Google your things. So Google your specific requirement, what you're actually looking for, and sometimes being too specific might be bad. So try to limit it up to 4 words. And yeah, there's a lot of articles that'll come up right up top that might help. Also, Kaggle is a very good place to find data sets and so on. So your 7 minutes will start now. Go ahead, do your thing, and
In the
we'll just
meantime,
be here.
yeah, and in the meantime, if others have questions, you guys want to ask us, you guys want to chat, that's fine.
Or just conversation, anything you want to
Yeah.
talk about, maybe the possibility of AI taking over the world, anyone, just unmute yourself, let's have a chat.
I mean, I wish this was in real life, like in university, it would have been so much more fun, but
I know, dang it. It's so annoying
Yes,
when it's not fun.
he's leaving.
Okay.
You guys can come over here, put it in the group chat if you guys want, or you guys can let us know, like, you can talk over here and give us suggestions, that's also fine.
Yeah.
Okay, so Akilan has Beat Accent Archive from Kaggle. So that's his suggestion.
Nice. Okay.
Okay.
Cool. What did you get?
For accented speech, wait up, I'll send it on the group.
Okay, in the meantime, Sid has got Game of Thrones Battle CSV. Which one is it for?
Fantasy world, right? Game of Thrones.
Yeah, okay.
Nice.
Why is this being so slow?
Okay, so we have 3 data sets. Nice.
Yeah.
You guys are quick.
All right.
Benjamin, how do you copy coursework? Skills developed somewhere.
Okay.
You too good.
Whoa.
See, it's all about how good you can Google. Like all those deep links you find somewhere hidden in Google. Yeah, that's where courseworks come from.
It's interesting the one that Aklan found, because it's actually the one that I also found for this and wanted to show just in case people didn't actually find anything and didn't want to interact. So yeah.
You do not have trust in the audience.
Just in case. Okay, I know how college students are. I'm a college student. I know how it is.
What? You think we're not sincere?
No, you're just lazy.
Whoa.
Whoa, yo.
Oh my god, I'm lazy too, okay? I'm just saying. It's the truth. It's a harsh truth.
It's a common trait.
Especially computer science. Why do you think I'm doing AI? Yeah? I want everything to be automated. I want everything to be done for me.
Yeah, like I said, glorified automation.
Yeah. Okay.
Okay, so we continue then.
Yeah. What about Vaibhav?
Vaibhav? I don't see him in the call. I think he left.
He's on the call.
He's there. No, he's there, sorry.
Yeah.
His last name starts with M.
Nothing yet? Don't worry, take your time. You have 7 minutes. Well, actually, how many
So
minutes?
nothing yet. Oh, actually, he didn't get anything. He tried finding for sentiments.
Yeah, I know.
Find
Even I have one.
Yeah, Benjamin, I found Indian accent speech recognition.
Oh Lord.
Oh,
Lord.
wow.
Oh Lord.
Of course
Oh
you
Lord.
did. I have 1.3 million people, bro. Of
What
course.
would that be? How would that go, man? What's an Indian accent?
Wait, I found a blog. I can't find
You
it.
don't know what an Indian accent is?
Benjamin,
Sure, I want Akilant to do
Benji,
it.
you have one.
Yeah, I know. You
I do?
have one. Akilan
Oh, okay.
doesn't.
To be more
Yeah,
specific, you have a very Malayali accent.
Yes.
Thanks.
Yes.
Whoa.
Never forget your roots. uh,
Wait, I'm sharing the link of that.
yeah. Oh, interesting. Okay.
Oof, Indian accent speech. Dungeons and Dragons! Did you have to? Okay, cool. Wow. What can I do with this data set? Yes.
Okay, I think 7 minutes are up. Yep.
Actually, 2 more minutes left because we started at 16. Okay, 1 minute left.
Oh well.
So Benjamin found another thing. There's another thing called Accent DB. It's like a database of accents, apparently.
Yeah, dude, I saw that too.
Use
Oh,
that
this
for
is-
something.
All
So
business stuff.
maybe for the chatbot for the tech club, yeah, we could use that.
I mean, that's only if we're gonna use speech to text. Otherwise, it's not very useful.
We came in opening a Google Colab, Benjamin. I think.
Oh, that's interesting. Okay. Okay, Vaibhav got something. He got
Found it.
Okay. Yep.
Oh, nice. That's
That's
great.
really good.
This is yes. Okay, so since everyone who wanted to participate has brought something in, I'm gonna move on with actually showing the ones that I found. This is the one that Webber found as well, multi-domain sentiment dataset. And for the speech, Google Speech Commands, there's a bunch of others. The Speech Accent Archive and Atomic Light dataset. Right. So, as we were talking about before, getting the appropriate data set is very, very important because there can be a lot that goes wrong with when it comes to having a bad data set like Benjamin showed us. So, one such scenario is is Tay Tweets, which basically was a venture that was she was an AI that was supposed to be a teenage girl on Twitter and interact with people and learn from them and respond and basically grow from the responses of her followers. So this started out well, it was very cute and nice, but then very quickly it spiraled into something not so great. So she started to become racist and Hitler-loving and anti-feminist and yeah, not exactly what they had in mind. So this is another example of data bias. And also let me clarify something. Data bias is a part of data aberrations, like aberrations in data. Bias is considered an aberration. That's why it wasn't mentioned specifically on its own in Benjamin's slide. Yes, so this is basically what happens when there's aberrations or errors or unwanted data in your data set. Format, relevance, reliability, credibility, and consistency are a few of the things to look out for in a data set, but manually combing through an entire set is laboring, so when the data sets get too large, we place a certain amount of trust in the creators that they did a decent job. So the importance is stressed so much because the wrong data set can lead to disastrous consequences like we just showed. Now, moving on, we're going to be talking about the actual project. So we're going to be creating a help bot. Remind me to think of a better name. We're going to be creating a help bot for hosting on a website. It's basically something like a customer support bot, except since we hope to host this on the Tech Club website, it's not going to be customer support, just a general guide and interaction. Like, it's supposed to interact with visitors and answer questions about the site and so on, and that is its core function, to answer questions, to chat with them, and give information on projects and members, if with consent, of course. As for the development, so we'll be using either GPT-2 or GPT-3, which is a text generation model, a predictive text generation model by OpenAI. GPT-3 is actually the newer version. However, there's a few issues with access. It's harder to get access to. So while we're working on getting access to GPT-3, we'll be using GPT-2 instead. So as the help bot is developed, we might add more functionality to it. So some additional features that it could have could include sentiment analysis to see what the visitors think of the Tech Club website, or text-to-speech, so that it's easier for users to communicate. Front-end design, I remember Pranav mentioned something interesting on the Tech Club chat. Document summarization to summarize any projects that we had, and so on. So additional features is something that we'll think about later, but this site is mainly here to show you that there is a lot of potential when it comes to a project like this, and it's not just any old random customer support bot. We're going to try to make it a test of our skill and what we can implement. So here's a few resources on GPT-2 and OpenAI software, and a guide on where to get started with the requirements and so on for training predictive text generation tool like GPT. So I'm not going to be looking at them unless you want me to right now, but be sending all these links on the Tech Club WhatsApp group as well as this chat. So yes, that's about it for this session. For the next session, just a really quick preview. We're going to be talking about AI in development, which includes the applications of AI, or more applications of AI than the ones that we've already covered, a few risks and myths that we will both discuss and debunk and maybe confirm, who knows, planning and development methods and how AI is developed in industry, and so on. And yes, that's about it. So really quick, does anyone want me to go over this if you're interested in the project, or would you like to take the time to go over it yourself? If you want me to go over it, Ben's already put it in the chat, and have you put it in the WhatsApp?
Yeah.
Yes?
Yeah,
Okay.
I did.
Great, cool. So it's all there. You can access it whenever you'd like. If you want me to go over any part, just, I don't know, raise your hand maybe.
Aanchal, for the data set, where are you going to get it from?
Right. So getting the data sets is, for the help bot, we'll be looking for data sets. One of the tasks was actually supposed to be for you guys to come back to us the next session with the data set that you think would be useful for the help bot. Because we haven't given you an exact scenario, right? Like, this is not a fantasy, or it's not the same thing as learning sentiments or speech or accented speech. What do you think is a requirement for the help bot, and what data set do you think will be useful? Next session, bring maybe one data set if you're interested in the project. And if you're not interested in the project, you don't even have to bother doing that. It's fine. So like I mentioned, you can find the datasets at Kaggle. That's one of the best spots to get datasets, and others you can find them on articles and other data, like other websites made for data sets, which I will link to you on this meeting and on WhatsApp as well. Yes, that's about it. Thank you for coming.
Thank you. Thank you, guys. Appreciate it.
Any questions or anything you want to bring up, anyone?
Are you guys going to host a project on GitHub or something, or is it?
Yes.
Yes.
Okay, that's it.
Cool. I'll put a few websites where you can find data sets on WhatsApp, and that's it. See you guys. Bye.
Bye-bye.